session is pretty much just TSQL. And the reason it's just TSQL is because TSQL is amazing. In 2013, TSQL was voted the best programming language of the year by those guys who, it's pretty a prestigious award to be awarded. Like other ones which have been awarded in the most recent are JavaScript, Java, and before that, loads of really impressive languages, but somehow TSQL snuck in there. Because TSQL is amazing. So what we will look at today, we will look at tally tables, cursors, hidden cursors, CTEs, recursive cursors, manual pivots, TSQL pivots, cross joins, cross applies, correlated queries, stuff. So window functions, Go, we'll look at a little bit of XML path, a little bit of mod, we'll look at some new features for 2018 or version next. Drop clean buffers, free pot cache, what these things do, statistics, IO on, and time. So a little bit of TSQL. Cool. So we'll do that by essentially looking at, so in my last job for about 3 months, I ran out of work, so I would just spend pretty much all my time on Ask SQL Server Central or other forums, just answering questions because it was just really dull. And it's a great way to force yourself to learn an awful lot really quickly, because it's like, oh, I don't know how that works, I'll go and have a look, and then it's like, I don't know how it works, oh, really cool. So lots of these were real questions that people asked on Ask SQL Server Central, and they are at least my answers, or I've since updated some of them. So it's pretty much all demos. If you have a better way of doing something, please shout it out and say, because TSQL is declarative, so you might write something and someone might write something and the engine will interpret it in the same way.
Sorry to interrupt. Order of firecracker pizza. Haven't got any fireworks sauce, so can I change it for one of the other pizzas? Yeah. Is it like a spicy?
No, I think it was just quite good last time.
Chipotle's close.
I want to.
Chipotle? Yeah.
Yeah, so if you have a better way to do it, please shout it out. So for some of these things, some of them there's a little bit of performance tuning thrown in. So rather than explaining them every time, there will be a couple of things that will be used. First one being DBCC drop clean buffers. DBCC drop clean buffers is essentially freeing the cache. It's essentially the same as if you were to restart it, so there's nothing in the cache. And also free prot cache, which clears out query plans. So every time we run anything, we're technically getting a clean plan, nothing's coming from plan cache. Then we'll use statistics IO and statistics time. Has anybody used them before? Yeah. So for guys who haven't, statistics IO and statistics time are a couple of settings that you can switch on, which enable you to see what's happening in your queries, as well as like the query plan. You can see scan count, logical reads, physical reads, and read ahead reads. So mainly we'll be interested in scan count and logical reads, but we'll have a look in a bit better. So, okay, question number 1. I work for a HR company, and I have data with periods of absence, and it's from A to B. So on a single line, they were off on one day and they came back on another day. But for reporting purpose, what they need is every single date in a list. So essentially, trying to almost unpivot. So, demo number 1. Anybody can have these scripts. Some of them are online already, but I've updated it. So it will just build a database called Tricky SQL and populate it with a date dimension, which gets used later, but is of no real interest. So query 1. So somebody posted this, they had their data, it was from A to B, they needed it in a list. And I did something very similar to this in, again, a previous job when I used to work with Access. In a former life, I was an Access developer for a good couple of years. So, you didn't have any of the good things of TSQL, it's very basic, so a lot of it was done in VB. Okay, so this person has given us a little bit of sample data, which looks a little bit like this. we'll stick a little index on there. So their data is from A to B. But what they actually want is they want they want their 8th to the 20th for each one of these. So from the 7th to the 20th, from the 1st to the 3rd. So the old Access developer in me would think, okay, what's the best way to solve this? And that would probably have been a cursor at that point. And I wrote a cursor at that point, and it worked. But cursors are inherently not great, and we'll have a look at it. But for those who haven't used a cursor before and are unfamiliar with cursor, I will teach you a cursor, and then immediately you have to forget how cursors work. But so the basics are, you'll declare a cursor, so you'll say, I am going to do something with this. You'll say, it's a cursor for this set of data. And then you will open that cursor and you will fetch a row from it. So what you're doing is you're declaring a cursor, loading it with a set of data, and then you will loop over it one row at a time. So you'll go for the first row, it'll do something with it, you'll fetch the next one, you'll fetch the next one. This is called a rebar function, which was coined by a guy called Jeff Modern. Really popular T-SQL guy. Rebar standing for row by agonizing row. Because essentially your rows will go through anywhere between your while and your end, or just loop over. So you'll do something. You'll load typically data into variables, and then you'll do something with those variables. Then afterwards, you'll close and you will deallocate them. So let's have a look. So this is a cursor to do that. So you've got a load of declares at the top. So we're going to basically load a whole load of variables of the different parts of holidays. Then there is a cursor here, which is saying select those holidays. So we're going to load this cursor full of our query. Then we are going to fetch a row from it, and we will set the first day with the first holiday that appears. And then after that, we will do a while loop inside a cursor. So it's essentially a cursor with a cursor inside to further loop over it and increment our data. And sure enough, it works. And really, it wasn't that bad. It took hardly any time at all to run and produce 52 rows. So not all that bad. But I mean, it could really be an awful lot better. So, as I said, with our cursors, cursors are inherently evil and should be avoided at all times. That row by row operation is horrible, and unless it's for like a maintenance operation, they should definitely be avoided.
So you would recommend it for something new?
No.
If you ever find one of these in any kind of reporting function that's going to go directly back to the user, then but if you didn't deviate stuff, if you're saying loop over a set number of rows to do.
If you're doing something something as small as that, it doesn't actually matter.
No.
So lots of like indexing, re-indexing functions and deviate automation used and shit like that. Well, it's fine because it's not that much.
So, what's the alternative? Tally tables. Do you guys use tally tables?
Have done before.
Yeah. Do you guys know what a tally table is? Cool. Okay, so tally table is just a table filled with a load of numbers. And a table filled with a load of numbers makes really complex SQL problems really simple. So let's have a look. So the problem that we had before, that we wrote our hideous cursor for, can be solved a little bit nicer with a cursor with a tally table. So, okay, I'm going to create a table. Or at least drop one for the moment. I'm going to create a table called tally table, which will have integers and dates in it. I'm going to just create a non-clustered index on that one as well, just to make some of this a little quicker.
I love that for you.
Yeah. Then this is the McCann style tally table generator. Now this thing is amazing. If you ever need a tally table quickly, this thing is fucking cool. So it looks quite complicated, but essentially all it's doing is the first one is saying select a 0 and then union with a 0, so it produces 2 rows. The next one is saying do the same but cross join itself, so it produces 4 rows. Then it goes 16, 2, 5, 6, up and up until you produce something like 4 billion rows. Then you simply just do a row number over by, and this is a window function. I won't explain it now because we'll have a look at window functions in a little bit. But we'll produce a Mahusive list of numbers very quickly. So let's insert some numbers into a table. And there we go. So it produces a table with just a whole load of numbers in there, 15,000 numbers. Way more than what we need for the demo, but you know, it's only 15,000. There are alternative ways to do this, and a popular alternative way to do this would be using this guy, which is a recursive CTE, so a recursive common table expression. What this is doing is a recursive CTE is almost based on functional programming, which is essentially write a function, the function calls itself, and it keeps calling itself over and over and over again until it fails out and moves out. So this will say, I want to keep incrementing a number until I reach 15,000, and then return those numbers. But this, and you commonly see it on like internet forums, somebody will jump in and suggest this method over the McCann method. And this is a hidden cursor. Although it may look like it's being recursive, people say, you know, recursive CTEs are really cool, I can write them, I'm amazing at TSQL. But really all they're doing is writing a cursor. And it is an awful lot slower. So I have a teeny little demo just to show the difference because it's really cool. So this is just looking at the recursive method with statistics I on and time on, selecting the top 100,000 rows, and also selecting 100,000 rows from the McCann method. And I'm just going to run them. They take a couple of seconds to run, and I just want to have a look and do a quick comparison of the different results which come back because they are quite interesting. So 100,000 rows returns, so the recursive CTE, which is technically a hidden cursor, returns in 7,500 milliseconds, whereas the McCann returns in 200 milliseconds. So, you know, quite an improvement. Was that something like a 30-40 time improvement? But the real key thing, the real key difference to note here is the first one produces a working table. So it's doing logical reads of, however many that is, 6 million logical reads against this working table. So it's constantly looping and looping and looping over this table. But what you'll notice in this one is there is no table. So the McCann method is a 0 IO operation. It does no IO. So it can produce a massive list of numbers just purely from memory. It has no working tables. It's very cool. Yeah. So, tally tables, really cool. Every database should have one, and they'll come in handy at some point. We're quite blessed in the warehouse market that we'll always have date dimension, which is always good for a tally table. So, in order for this to work as well, we need to look a little bit at cross-apply. So, I have another quick segue to explain cross-apply. Presumably you guys have used cross-applies. Maybe you guys have not. Cool. So one function that TSQL doesn't do very well is what's known as correlated queries. So you may want to, in your query, actually then say, oh, I want to go and get something from another query. And you'll sometimes write a query out and it just won't work. You're like, oh, why can't I get it to work? And it's because you're trying to use the value that gets returned from one query to then feed another query within the same query. And it gets really complicated and it gets a bit caught up on itself. And this is known as a correlated query. I need a table from another one. Oh no, I don't. I need that table. So just going to use the same dates again. So these are the same dates that we had before. But this time I'm going to use my date dimension. And what this is a correlated query. So what I've done is pushed a SQL statement into my select line. So we're selecting a whole load of stuff from an outer query. So this section here and all of this bit here relates to one query, and then this guy is a correlated query who is referencing a part of the outer query. So there's an outer query and there's an inner query, and the result of this outer query we pushed into the inner query to return a value. So what we're doing here is saying how many days were there between these two dates. So if you run it, it will go away and bring back a value. There were 14 between this day, there were 3 between this day, and it does that through a where clause which references the tables on the outer query. So this guy down here is ed, and this is saying I want to give me the count of the rows that come back where the date is less than the holiday to, or is more than holiday to, and is less than the holiday from, which is cool. So that's a correlated query. Correlated queries are good, but they will only return you one value. You can't do a select star in here because it doesn't really know what to do. It will just fail. It's like, well, you're trying to pass me in multiple columns. I don't even know what to do. So you could go, okay, well, I want to select the max day or something like that, and then copy and paste this again, put another line in and do another one, do another one, do another one. And you can do that, but it's not great. So this is where cross-apply comes in. And cross-apply is essentially like a join, but it's a calculated join which is calculated against the outer query. So it's exactly the same query that we have here, but this time we pushed it from our select line down into our from, and we're doing the same thing, so we're cross-applying with exactly the same conditions. And then this time I'm able to select multiple columns if I wanted to. So I've got a count star here, but I could choose the max of something else from that week number. I don't know if that's real. No.
No, you need to bring it back in the cross-apply SQL query.
Oh, I do. That's true. So if you add more things in here, then it would work. So the basics of a cross-apply. We had an example with a customer recently where they have renewal periods, and their renewal periods work in a very similar way. So rather than every renewal being a new row in the order table, every table, essentially if a policy is auto-renewed, the close date will just get implemented by a year, and the values will remain the same, and they'll just keep charging them again and again and again. So what they have is they had a requirement to say, oh, we actually want to see this on a row-by-row basis, so we can say, okay, we sold 100 policies in 2015, but the original policy would have been 1 in 2001. So what they needed to do was generate additional rows, and cross-apply is very good for doing that. So this one here, slightly different data set, but what this one is doing is, again, it has a date from and a date to, but this time I'm calculating years based on a date difference of date and a from and to, and dividing it by 365. So a bit of a brute force way to calculate how many years. Could have done a year count or something like that to work out how many years. So what I know here is I want to create a different, I want to keep this original from, I want to increment it by a year, and then insert another row, and then do that 5 times. So I have 5 different periods from one row, and tally table and a combination of this works really well. So what I've done here is a cross apply to my tally table, which I created in the last one, but this time I'm going to select the amount of rows for each one. So where there's 5 years, I want it to return me 5 rows. So as before I was doing a count start, it was only returning me 1 row, so I was only getting 1 row back. This time it's returning 5 rows. It will duplicate my data by 5 times. So if I run this, you can now see here, for this one here where they had 5 years, we've got 5 years being duplicated, all the dates being duplicated, and then an additional column which is added on, which is tally int. Cool. Yeah, so this has added 5 rows for all of the years, and then this one down here where there's 15 years has added 15 rows. Then with a little bit of additional TSQL, so we're doing a date add here. So this function will essentially take the date, add on a year based on the tally integer. So the first one I wanted to add on 0 years, so saying tally -1, which would be 0, tally 2 -1, which would be 1. So we'll add on a year for every single one. And then to get the end date, we want to do the same, but we want to minus off a day from the end of the year. So it's doing a date add day -1, which if you look, returns you from those from that one query where we had 1 row and 5 periods. We now have 5 rows where the start is in the 1st of the 1st 2001. It runs up to the end of 2011 to the end of 2011, then 12 to 12, 13 to 13. Cool. If I get to the end of problem 1, I'll eat some pizza and then carry on.
Yeah.
Cool. Okay, so that was the basics of cross-apply, combining it with a tally table. So now we can reapply it back to our horrible cursor. So we had a horrible cursor, which was this guy. And this guy was looping over and doing essentially 2 cursors to produce us a whole load of dates. So again, like Si said, if this was in a reporting, so somebody could do this, stick it in a stored procedure, stick it in reporting services, and it would work for 5 rows, and then people scale it up and it doesn't work. And I had that when I did it in Access, and we added more and more and it didn't work, and it was like, why doesn't it work? It works with one person. Yeah, so awful. So if we instead look at it with our tally tables and our cross applies, we can run this little guy, and it's doing the exact same operation. So the holiday from and the holiday to, it's producing us the 7th, 8th, 9th, 10th for all the rows that we required. But this time, rather than using a cursor, it's doing it in a set-based approach, which TSQL likes, and so it's a set-based language rather than a row by row. And again, this is doing it through a cross-apply, selecting the tally date, where the date is between that range. So we have a range up here, and it's just extrapolating that range into a whole list of values, and each row gets duplicated. So that way works well. And both of them ran in about the same amount of time, hardly any time at all. But what happens when we up the amount of rows? Do you guys know? So presumably, you guys have all seen Go. Thank you. So Go is a batch separator. Have you ever done a Go with a number at the end of it?
Yeah, I have.
Yeah. So Go with a number at the end will repeat that statement however many times. So I'm going to repeat this insert statement 100 times. So we now have something like 3,400 rows. So we've sort of like pushed it up a little bit. So we'll run our cursor again. Run our cursor, and we wait. So again, it's not too bad. This time it takes 6 seconds. I was at a user group and somebody said, "Oh well, can I see the query plan? I want to see the query plan for this. You know, I want to see how much worse it is." And he asked, and I refused, because you can't see the query plan for this, or you can, but what you'll actually see is 36,000 query plans, because each one of these is running its own query. So yeah. So what you'll see here as well is for our SQL statistics IO, what's actually happening here is each one of these isn't about the query, rather it's about the individual operation that's happening, so you have got a shit ton to try and get through. Whereas, if we do our set-based approach, our query is done. Sure, it does actually quite a lot of heavy lifting. There are an awful lot of logical reads, but it's an awful lot quicker. It's set-based. It wins. Let's eat pizza then.
Yeah, cool. There's a lot of anger pent up inside a lot of this.
We're a community.
Single family.
Yeah. I've got people that are like.
Like, you know Calvin, don't you?
Fair.
Yeah. And Calvin was out in the past with this. Calvin was like this really young looking guy. Very, just wasn't that young, but just had a very baby face, didn't he?
Yeah, one of our clients rang us up and said, why have you sent us a 12-year-old?
That's what that was, honestly. And Stacey and Meisner and Calvin, it was literally like I was imagining Calvin going back in a nap again, probably
Just mothering him in.
Yeah.
She's nice.
Yeah, she is nice.
She's one of those that she came and did the first Saturday, and then I saw her like a year later. She's like, "Oh, Terry, nice to see you." And I was like, "You didn't have to remember my name." So yeah, she's nice. Right, so I on. You carry on meeting.
Yeah, Gavin.
Yeah, there are good people, and then there are dicks.
Hi.
Yeah. Hi. Okay. Timetables are good. Okay. This question I loved. When the guy wrote it, before I even wrote an answer out, I was like, great question. Like, kissing his arsehole. It's a great question. The guy was trying to equally distribute customer records to employees at the same branch. He had a maximum assignment value, but it didn't really apply. So he had two input tables, one which had customers and the other one which had employees, and there were 11 customer records, and what they basically had was 11 customers, 6 at one branch and 5 at another branch, and these branches had employees. One branch had 3 employees, one branch had 2 employees, and he needed to evenly distribute these customers to these employees. So the desired result was 6 customers at one branch equally distributed between 2 employees at that one branch, and the 5 customers at branch 2 equally distributed between 3 employees. So how do we go about doing something like that?
Sounds a bit heavy.
Yeah. Yeah. So the guy was really good as well. So if you get stuck and you need to post a question, post things. So do create temp table scripts, temporary load it with a load of data, and it just makes everybody's lives an awful lot easier. Okay, so he had this. So he had these 5 employees, of which they work in branches, and these 11 customers who are associated to a branch. So branch 1 to these. So he wanted to take, say these 3 people and give them to employee 1, and he wanted to take these 3 people and give them to employee 2, and then do the same process for these guys to these guys. So, looking at this initially, it was like, okay, how could you do it? And again, I was like, well, tally tables solve every problem, and yeah, they do a bit. But what this one really benefited from was window functions. So I have I want to say it's a short demo on window functions, but it's not. It's quite long. Window functions, like we were sort of discussing, are not new. They're new-ish to SQL Server. They came about in 2012 or somewhere around about then, and they are absolutely fantastic for a whole variety of reasons. So this is the basics of a window function. You can think of it, they're called window functions because they're also called analytical functions, but they're called windows because they create a moving window within your subset of data. So what this here is doing, you have a row number. So row number is the function, and you're saying I want to produce a row number over a subset of my data. So it's saying a row number over, I want you to partition my data by something. So create a partition in that data by employee. So if there were 100 employees, it would create 100 partitions in your data. Then it will order that by a particular attribute and then apply a number. So you can see here, partition by has created two windows. Partition by the employee ID, so we have those 5 employees, we have those 6 employees, and then ordering, and it's produced this column here. So this is a row number, so it's producing a number for every single row. So this is doing a order by sales date, so first sales date, second, third, fourth, fifth. Really cool. Window functions are great. There are quite a few different window functions. There's a row number that we looked at just then. And these ones, the rest of these other two do the same sort of thing but different. So it really depends on what you want, and you need to be careful in what you're doing. So a rank produces you ties and gaps. So if you have the same number, and so you have 2 people who are tied for first, and you have somebody who is third, what will happen is row number would have given you 1, 2, 3. Rank will give you 1, 1, 3. Then there's dense rank, and dense rank will give you, in that same example, 1, 1, 2. So it has ties, but it doesn't have gaps, it's always sequential. Then there are lag and lead, and I don't think lag and lead were in 2012, they came a little bit later. Were they?
No, they were 2012.
So lag and lead are great. So within your window, you can say, if I'm on a particular row, I want to know the row 1 row before, 2 rows before, or after. So yeah, so looking at each one of these, so you've got a particular column there for row number, rank, dense rank, lag, and lead. So we've got 2 different things happening. So the first 3 are by partitioning by the score date. So these are fictitious guys from Game of Thrones who've gone to take SQL Server exams, and some have done well, some have not done so well. So on the 25th, Rob, Eddard and John went to take exams. They all passed those exams, and we wanted to have a look at who did the best, or rather who did the worst, as I've done that the wrong way around. So row number, it should be, so row number 1 has produced a 1, 2, 3 because they got 700, 850, 850. Then rank has produced a 1, 2, 2 because there's a tie, and a dense rank has done the same. But if you have a look at the next group down, so the 22nd of March, we have a slightly different way around. So the first 2 are tied, and then the third one is separate. So for rank, you've got 1, 1, 3. For dense rank, you've got 1, 1, 2. So depending on what you're trying to achieve, there are different functions for each. And then flipping that a bit to use the lag and lead, we're partitioning this time by the username, so we're creating 3 partitions. Then we are ordering by the score date, so when they were taken, and we're taking the lag and the lead of their scores. So what we're saying here is on the first row, zoom out. So on the first row, Eddard, he got 850. His lag is nothing because there was no previous score. But when he got 699, his lag was 850, which is, that one over there. Then his next one that he took was 900, which is that one. So lag and lead allow you to do things like, I'm on a current row, what was my row previous, what's my next row? And that stuff, prior to 2012, without these, it was really difficult to do an awful lot of queries. So cursors were pretty much the only way.
Or joining to yourself as a giant
Yeah. Lots of self-referencing tables. Made things really difficult.
The row number is like daddy of functions, I think. It'll get you out of so many problems.
Definitely.
If you want to deduplicate data, a row number is your friend.
I completely agree. So, I have an example of some window functions. So those are only a couple of window functions. There are technically windows that you can apply in multiple places as well. So what we have here is a couple of dates. Employees, they made some sales and they made some sales on those dates. And we can say, okay, well, what was the first one? So we want to know for any employee what was the first sale they made. So we can do that by applying a window function. So we can see first sale, this row here was the first sale for that employee, which was made on the 5th. And this one was the first one for this employee, which was made also on the 5th of January. So that's cool. And you might then want to say, okay, well, I want to only return the rows where it's equal to the first. So when I first started doing this, I assumed I could just do something like this. I could say, alright, well, I'm using a function here, I can just add it into my where statement. Will it work? No, it will not work. So for Tonga and Callum, do you know why it won't work? So it's a segue, but it's a segue worth going down. So in the back end of SQL Server and in SQL in general, you'll write a query like select from where group by having order by, and it's known as a logical processing model. But it's not the way that the engine actually runs these queries. So it will run them in that order. So you'll be taking data from somewhere, you'll be reducing the amount of rows with your where, you'll be grouping those rows, and then with a having clause you'll remove those groups. So you end up with a small subset. Then at the end you select your data, and then you order it. So what we have in our query currently is we have a function which is being applied at the select level. And it's sort of operating in a similar way to a correlated query almost, which basically means it won't work. And there are ways around it, and they're a bit clungy, they're not particularly nice. One way is to wrap everything in a CTE and run it, which works, but essentially we're doing two queries, but it's a way around that sort of thing. So window functions aren't just limited to things like rank, dense rank, lag and lead. You can do a window function on any aggregate. So on any aggregate being a sum, you can do a sum over by a partition of an employee ID. I'm not sure why you'd want to, but you can do. It may be a particular reporting requirement that you may want to see. You can do an average over by a partition. And this creates some funky looking data. So it creates a data set that looks like this. So what we have is we have the sum, average and count. So we have the sum of the sales per employee, so that's all of those values. They're summed up and cascaded on every single row. So you may want to do a calculation that says, okay, for my employee on this particular day, he made £100. What's that of the total amount he's ever made? How significant is that value? And that would be very difficult to do normally, but to do this way, then you just divide one by the other, and you'll get that. Again, you can say, what's that difference to the average, and how many sales has he made? I don't know.
It allows you to bring an aggregate in with the detail.
Yeah. So there's a rule of thumb when you use aggregates, and the rule of thumb is always if you're doing any aggregate, the easiest way to always make things work is to group by all non-aggregates. So what you have in this query is, so if you were doing the sum of sales amount, the average of sales amount, and the count by the employee ID, sales amount, and sales date, these would be your non-aggregates. So you would always have to put them in your group by. But what you have here is essentially an aggregation happening where there is no group by. So this is almost an inline aggregation without a group by clause, which always feels a bit crazy to me.
I think there are some instances of that in the school system.
Yeah.
So, can I take a look at that?
Cool. Yeah, aggregate functions with no group by. Crazy. Okay, so now we know a bit about window functions. So the next thing we need to look at is mod or modulo. And it's one of these functions that exists in tons of different databases. It's a mathematical function. It works out the remainder of things. So I can't testify to knowing exactly how it works, but I know enough to make it always work for what I want it to do. So a typical example would be like 10% is mod. SQL Server doesn't have a mod function. If you were to use Oracle or MySQL or something else, you can use the word mod and it will work. SQL Server doesn't, it uses percentage. So 10% 2 should say how many times does 10 fit, or if you put 2 into 10, what's the remainder? So mod 2 should say no remainders. If you do it on 10 mod 3, it will remainder 1, because there's 1, it goes in there 3 times of 1 remainder. If you flip them, it produces a bit of a funky query. And it essentially does a very similar thing, but a little bit flipped. So a 1 mod 7 produces a 1, a 2 mod 7 produces a 2, a 7 mod 7 produces a 0, 7 goes into 7, 0, and 8 mod 7 produces a 1. So what it allows you to do is take a large number and partition your numbers into smaller numbers. So I don't remember if I showed it. On the day away, as part of, I can't remember if I demoed a popper, and the popper essentially takes a whole load of packages and cascades them across cores, and if you've got 16 cores, it will evenly work out. If you've got 100 packages, divide them in 16 ways and produce them into 6 parallel streams. So that's all done using mod. It will work out, if you've got 100 packages, you've got 200 packages, it will work out how to evenly distribute them. Which doesn't really work because one package could be really big and another package really small, but it evenly distributes them based on numbers. So things we know already, we know that we need a tally table, not a tally table, we need window functions and we need mod. And we can start pulling this together. So this is a part of the problem, or part of the solution. And what's happening here is we are selecting the customer ID and the branch ID from our customer records. So our customer records contains 2 things of branches and customers, and we are doing a row number to work out which particular branch they're in, and then we are doing a correlated query to work out how many branches there are. So, or rather, these should be flipped. That should say number of employees. So what we have here is we know there are 2 employees for one branch and there are 3 employees for the other branch. And this is working out to say, okay, I want to do a row number partitioning by the branch and by the customer, which produces us a sequence. Then we're doing a mod of that sequence over the amount of employees that that particular branch has. So we have here 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So that's the sequence. This is the amount of branches that they have, the amount of employees that they have. So this is doing a 1 mod 2, a 2 mod 2, a 3 mod 2, and it's producing this number. But mod, we saw before, 7 mod 7 produces a 0, and we don't want to attribute this stuff to a 0 employee, we want to do it to 1. So I just add a 1 onto all of these. So 1 mod 2 will produce a 1, but I inflate it to be 1. So all the employees get flipped, but it doesn't particularly matter. So what's happening here, you can see, is this particular customer record here will be associated to employee 2 of that particular branch, that one to employee 1, 2, 1, 2, 1, and then we go down here, it will go 2, 3, 1, 2, 3. So they're being distributed, and they're being evenly distributed, but there will be one who falls out because there's an odd amount. So that's part of the solution. The next bit would be to work out where to associate them. So I'm just going to add a artificial index onto our employees. So by doing a row number, again, as Neil said, row numbers are magic. By partitioning on the branch ID and ordering by the employee ID, I can create this artificial employee index. So now when I have the other query, which went 2, 1, 2, 1, 2, 3, 2, 1, 1, 2, That will work in the first record will go to this guy, second to that one, and then until we get down here. And then we join it all together with a couple of CTEs. So this is the first statement, this is the second statement, and then we just combine them together, and we end up with pretty much what the guy was looking for. So you have a branch, another branch, and of the 6, they've been evenly distributed between 2 employees and evenly distributed between 3 employees. So I thought this was an awesome question. It's one of those things that shows sort of why TSQL is the programming language of the year in 2013, because it's so versatile. You can do just so much like little stuff. And again, it's one of those languages that people say, oh, is SQL hard? And it's like, no, it's not hard. The basics are select from blah blah. It's fucking easy. But then you can get so deep and so complicated to the point where you're putting top binary to produce random query plans that cause parallel stuff, which is really pretty cool. Yeah. Good. Problem 3, and yeah, so back to the slides.
It's reminding me that I need to get the code digest back over. Yeah. Yeah,
Second.
it's coming up soon. It's like 2 weeks.
Cool. So the third one, and the third one's like a personal favourite of mine, and when I realised I could do it, sort of like blew my mind. This was back in the Access days, and this was Access 97 as well, so it was pretty shitty Access. I hate Access with a passion because of all the pain it caused me, but on my master's degree, Tom guy Mark Whitehorn, who runs the degree course, he co-wrote the relational engine that sits behind Access. So when I was sat there when we went out for dinner one night, absolutely bitching like the shit out of it, and he was just like, I wrote that. And I was like, oh, fuck. So yeah, so this guy wanted to see the sales per year as a column, not as a row. So he's got a whole list of data which has the person who made the sales, the date that they made the sales, and the value that they made it, and he wants those across the columns. So you're thinking, yeah, pivot, cool. So the intention is to produce a report which looks at sales comparing year on year. So he wants to say, okay, this year compared to this year compared to this year, have our sales for a particular product gone up or down? And he wants to see the flow of it. And then he was like, well, you guys like a challenge. So what I want to see is the top 3 most sold products for a customer. But again, I don't want to see them as a list. I want to see product number 1, product number 2, product number 3. So let's have a look. So this time we're going to use AdventureWorks because we need a bit more data. So I've got AdventureWorks 2014 installed, and this is our sample data set. So we have got a whole load of employees, a whole load of dates that they did something on, and the amount that they essentially sold. So this is customers rather than salespeople. Customers, dates that they purchased stuff, and how much did they purchase. But what we want is this as a year, and then we want every sale made in 2011, every sale made in 2012, 13 and 14 as columns rather than as rows. So one of the ways that we can do that is through, this is our data aggregated. So what I've done is I've stripped out the month and the day just to give the year using the year function. And then I've aggregated it by customer. So what we have is aggregated at the customer level. This customer has made a whole load of sales in 2011 and 2013. Didn't make any sales in 2012, but that's it aggregated. So one solution that we have is, which I don't know if it has a proper term, but I like to call the manual pivot. And what this can do is essentially using a case statement separate our data out. So what we have is a case statement which has a whole load of nulls. So we're saying, when the order year is 2011, then give me the total due. When it's 2012, give me the total due, 13, by customer. So then we're not grouping it yet. But so this customer made some sale in 2011. And then what we end up here is they made some sales in 2013 too. And we end up with a whole load of nulls here, and a whole load of nulls here, and a whole load of nulls here. Which isn't necessarily the behaviour that we want. We want a single row, the sales they made in 2011, and a single row with the total they made in 2012, 13 and 14. So we can add an aggregation in. So one of the great things about nulls is when you aggregate a null and you do a sum of a null, it will ignore the nulls. If you do a maximum of a null, it will ignore the nulls. So by doing a sum, we can flip this around, so we then end up with null, null, and then the sum of R for 2013 and 2014. And essentially all our data has been collapsed. And this is a manual pivot. It enables you to do things like, what's the value of this compared to this, compared to this, compared to this. I know it's on the tip of all of your tongues, I can tell. Why don't I just use a pivot statement? And you could use a pivot statement, you could write it out. I can never remember how to write a pivot statement for the life of me. I can never remember the structure of a pivot statement. It's just so laborious and just, it's not intuitive. But to me, this is intuitive. And you're thinking, okay, well, surely this TSQL is bound to perform better than this. And actually the performance difference is incredibly negligible. There is hardly any difference in performance. And again, because TSQL being a declarative language, it gets compiled, and I don't know if these come out the same or very similar.
I'm glad you said this, though. I've actually written one about last week I wrote one just like the one you just done.
We're about to go on to the how you should do it.
Oh yeah, it's very shit. Now I'm really sweating.
No, so a comparison, okay? So the which way around will they? I think the top one is the pivot statement, and the bottom one is a manual pivot. So the top one. So again, this is our statistics.io time and statistics.io. So we have, this is the TSQL version. It's working over 1911 rows. Our other one is 1911 rows, same query essentially. It's doing one scan and 689 logical reads and 2 physical reads. This one is doing exactly the same. Again, TSQL, the great thing about it being declarative is runtime, regardless of what you write, it's going to be interpreted by the engine and come out with a query. So the TSQL version ran in 47 milliseconds, whereas the other version, the manual pivot, ran in less. You can run this 5 times and they'll flip. There is no real rhyme or reason other than the amount of time pretty much that the data is being generated back. I'm pretty sure if you looked, they'll be generating the exact same query that's hitting the engine. So it's your choice really, how you want to write these things, but it's just another option that you have pretty much available to you. So then you can get that a little bit more complicated. So the guy said that what he'd like to see is the top 3 sales, the top 3 products sold, but again not as rows but as columns. So we can do a very similar thing, and it looks a bit like this. So what we have is for a particular customer. This guy was very good. He said, if there are competing rows, I don't really care. I just want to see the top 3. So if you've only sold one of every product, I don't mind which order you return them in. They're all equally significant, which is good because they would have made it really complicated if you hadn't. But this guy was good and made up. So that also helps. So this particular customer, we're looking at the order quantities that they purchased. So they only ever purchased one of each one of these things over a period of time. And we're interested in the top 3 that they sold, so these 3. And then for this one we're interested in that 3, and this one we're interested in those 3. So what we were looking at before with limiting our data out based on a rank, while it's not particularly pretty and requires the whole query to be calculated, we can do it. So it's the same query. So we can apply a CTE to limit our rows down, and then we can apply a analytical function again, a max, an aggregate function rather, to, let's take these off so you can see what actually happens, otherwise it's not as cool. So what we end up with is a query that looks very similar to what we had before, with our numbers where we had lots of nulls. So we've got our first record, null, 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 second record, null, 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 third record, and then a shit ton of nulls, which is not what we want. We want the first record, the second record, and third record, all those nulls gone, all of it collapsed. And you can do aggregate functions on character strings, because they are alphanumeric. You can do a max of A, B, C will produce a C, because C is the highest in an alphanumeric sense. So you can do this and take the max of all of those values. So again, because it's those other ones are nulls based on our case statement, all those nulls get collapsed and we take the maximum value. If there happen to have been two values, so we've taken the maximum of them, but our row number enforces a sequential number of 1, 2, 3 rather than 1, 1, 2, so we can guarantee that we eliminate those. And yeah, that is one way that you can do crazy stuff, getting pivots with text and fun things. Yeah, which I think answered his fictitious question, so cool.
As long as he was particularly happy, it's fun.
Well, exactly. That was pretty much it for the core. And then I left, depending on time, I don't know what time it is, I left a couple of, we've done logical processing model, but there are 4 things, or if anyone has any interest in seeing any of them, I am more than happy to show them. Any interest? Pick a number. Number 5. Okay. So,
20 past 8.
20 past 8, so what, 10 more minutes? Yeah? Okay, 10 more minutes.
Anybody else want anything?
Okay. So, on the 15th of November, one day after my 30th birthday, SQL Server, Microsoft clearly missed it by a day. It was obviously going to be my birthday present. Released the CTP one of SQL vNext. It's not SQL 2018 yet, it is SQL vNext. So with that, the only interesting thing that I've managed to find is one function. And that one function is string aggregate.
Oh yeah, I was looking at some of this earlier. Again,
so we've looked at a couple of aggregates. So we know we've looked at some aggregates which work on strings. So max, min, they would work. But we couldn't do a sum of a string because that would be nonsense. We'd end up with an error. It wouldn't be able to do it. So they've come up with a function which they've stolen from Postgres, which Postgres probably stole from Oracle, which Oracle probably bought when they bought MySQL or something. And that function does a very particular thing which in reporting services was always a pain in the ass. And it sort of worked in reporting services, but we wanted to do it in TSQL, it was tricky. So that was producing a list, a comma delimited list of values. So this is the P-now Dave solution.
Hey, fucking SQL authority, Jesus.
His name is P.
He was handing out his book.
Sure he was.
This is Penal Dave. He has the strangest name ever. His name is Penis Dave.
Yeah.
So Penal Dave had a solution which his name is Penal Dave, or Penal Dave, or Dave Penal, but it's
not an E.
yeah, but it looks like Penal. So this function is this is essentially, again, it's like a hidden cursor, because what it's doing is you are declaring a variable, then you're selecting that variable and pushing a value into that variable, and then selecting it again. So what it's doing is just looping over data and producing a list of strings, which works okay for one value. But when I want to say, okay, I've got these top 3 products that we've sold, I had them on columns, but now what I actually want is in one row, and I want them comma delimited. That's really tricky. That's always been really tricky. So there's been a couple of solutions. One of those being shitty XML path. Which for the life of me, I don't write. I take this statement and I make it work, and I never understand it, and I hate XML. But
yeah, that stuff function is just odd, isn't it?
stuff, yeah. So stuff is like magic. Again, it's one of these functions that I read about and I look at it and I go, alright, it works.
Yeah.
I have used that design pattern so many times without actually going in and going, what's that doing? Like,
Yeah.
that's how it works.
I've used it once or twice, but then you just forget it very quickly.
Yeah, so stuff does, you have a string, and then you say where in the string you want to replace part of that string with another string. But then somehow that means smart people can make it do magic. So there's a guy also who used to creep around in Ask SQL Server Central called Kev Riley. If you ever want to go to a session that will blow your mind on TSQL as much as McCann, Kev is incredibly humble and fucking smart on TSQL. So like when I'd answer questions on there, my entire purpose wasn't to answer the question, it was to answer the question before Kev. Because he would come up with the same solutions, if not faster or more elegant. And again, perfect reason why TSQL is so fantastic is that, you know, you'd sit there and work out this amazing solution that would take you an hour, and then he'd come up with a thing, oh, I just had a look at it and knocked out a query, it's faster, it's fewer characters, and it's better. As you can see, this is still running. It will work. It's probably returning some values by doing XML wizardry stuff. Yeah, cool. That's good, but that's a pain in the ass. So the crazy minds at SQL, at Microsoft, have switched my virtual machine off. We never meant to. So, as keeping with their recommendation, I've stuck it on a VM for the moment, as it is apparently a bit dodgy. And yeah, this VM crashes all the time, so I don't know if it's SQL crashing the VM or what, but it does keep crashing.
That sounds like a CTP1 thing.
Yeah. So yeah, this is proper CTP1. This is the latest and greatest management studio. This is the version 17. Again, when you install it, it says, shit happens, it's not our fault. So, yeah. Okay, so I have AdventureWorks, again, installed on here. And again, we have pretty much the exact same thing. So we're looking at our top 3 things sold. I ruined it. Our top 3 things sold, which is this query. But now we have a new function from Microsoft called, I can't do Zoom, sorry, I'm in a VM. But string aggregate. And string aggregate will essentially take a string or a function or some other form of functions and combine them and then append something on the end. So a simple one would be to take this one out and to say give me the string aggregate of the name, and then I don't know, delimit it by something like a pipe. And you run that, and that will produce you. Oh, sorry, I keep pressing to zoom in, and it won't zoom in. If you can see, just about you're getting a pipe and a pipe and pipe. So it's doing an aggregation and producing you back a string. Depending on what you pass in, you'll get something different back. So if you pass in a nvarchar, you'll get an nvarchar back. If you pass in a number, you'll get an nvarchar back. If you pass in a varchar, you'll get a varchar back. There are various things. They're working on it and they're improving it, but there's a whole list of what you'll end up getting back. So you may want to do some stuff with it. I don't know. Probably. That's a sort of interesting use case for it. So again, you can't really see. No. So this is doing a string aggregate, passing in a concatenation function. So they're concatenating the first and the last name, plus the modified date from the person. So the last time a person was modified, and they want to see every single person. So presumably an admin function or a report, someone who skimmed through this data, all wrapped up in one single thing. And you could append something else. That char 13 could be a char 10, char 14, and you just get a line break in that space. Character 10, sorry. Yeah, that's pretty much the only interesting thing in CTP1 at the moment, but it's cool. Yeah.
So looking to remember how XML path works.
Yeah, exactly. And the amount of times where it's about reporting, just in particular, you'd have products, all that stuff. It's just such a pain in the ass. I would always just do it in reporting services or something, and again, it's probably just a cursor when it hits there. Yeah, I've got 3 minutes. 3 minutes to talk about Friday the 13th. So, there is a smart guy in Slovenia. All the Slovenian guys are very smart. This guy, Thomas Katzum, does lots of stuff with R, lots of stuff with TSQL. When it was the last Friday the 13th, posted a TSQL challenge, which was write a function in TSQL, the smallest you can, so that you could tweet it. That would produce you the rest Friday the 13th for the rest of your lifetime or something. So he started out, and his best attempt was 276 characters, and I was like, I can fucking beat that. That's cool, but I can do it. So I wrote one, and this is my first attempt, and it was 329 characters. So I didn't like Thomas's, because Thomas's is a cursor. Essentially, it's a while loop. So he's producing them all as one, which was fine. That was what he was going for. And he did that using a begin and an end looping over the data. So my version was a set-based version. So I again used the magical row number, and I did a date add to work out the Friday the 13th, and then a where clause where it was the 13th, and part of the week was the 5th. And it wasn't very good logic, but it worked, and it produced you Friday the 13th in a list much faster than Thomas's. But it was bigger. So I wasn't happy with it. So I was like, right, I could probably make that smaller. So I was like, cool, I'll make it smaller. So instead, I needed a tally table to do this, because I needed to generate tons and tons of numbers. So I was like, what's the smallest way that I can get a tally table that I know that every SQL server will have it? So I was like, okay, OS performance counters, cross-join itself is going to produce me a massive list, because there's like thousands of performance counters. So again, that's what I did, and that produced me the same query again, but this time slightly better, 254, so not enough to fit in a tweet. Was what, 244 characters. I was like, right, I can do this, and I bought a lad at work a mug which had loads of facts on, and it had a fact, and I can't remember what it is, but I wrote it somehow into this query, which is, if the month starts with a particular day, and that particular day is the 7th day, the next day will be a Friday 13th. There's some logic. So I put that one in, and it worked. 126 characters. So I was like, yeah, I'm the winner. Tweeted it like, yeah, feeling pretty good, like no one's going to beat that. That's a tiny little number, n plus 12, doing some crazy stuff to work out the thing, and I'm using syscolumns to do it. And I was like, yeah, that's cool. And then, do any of you know Mladen Prajic? Again, a Slovenian MVP, lovely guy, fucking smart, comes along, and he's just like, aha, my query is better than this, in the way that only Mladen can do, in his Slovenian accent. And he comes back with this. which is only 84 characters on a single line, and he had things like to write ha 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 ha. My queries are a lot shorter, and yeah, and does, and it just loops forever because Aladdin is a very smart MVP, and this thing just goes on and on and on and on, producing you the Friday the 13th. But again, TSQL language of the year 2013, because it can do, you can go from a 400 character thing to an 84 character to do essentially the exact same thing, just based on how well you know the engine. And I will leave it there. There's some pictures of René Descartes if you want to look at Cartesian products. And that's it.
Awesome.
So,
That was very, very good presentation. Really.
good. Yeah.